This is a guide on how to set up a competition style drift car. So I'm going to be doing a test with the Assetto Corsa Drift France vehicles. And so that's a drift car pack that you can download and it's free. And they have really well modeled vehicles and they're honestly pretty accurate to I think what you would experience in real life. So I think these are a good example. Essentially, what makes this a competition car is that this has a realistic amount of horsepower that you would see in actual competition. So it's making 800, 900-ish horsepower, and it is fully adjustable like a competition vehicle would be. So I haven't done any kind of setup on this car. I just have it ready to go here. And so um, with all the adjustments available, we won't really worry about the gearing and the gearing sets. You can actually adjust essentially not only just the final drive, but you can actually adjust the gearing sets themselves. So you can have more control over the power band and just be a little bit more specific with your needs. But we can't really know this until we test it. This car makes a lot of horsepower, and so having first gear top out at 66 miles an hour probably isn't unreasonable, as just simply putting your foot down will blow the rear tires off anyway, and so we won't sweat about that. What we will go ahead and adjust even before we drive is start setting the tire pressures. And this is simply based off of previous knowledge. So the car itself is lightweight, as you can see, it's stripped out and everything like that. And so we can go ahead and drop this down to a pretty low number. Also note that the tires are pretty wide, and so you can actually use a deceptively low pressure amount in the tires. I'm actually going to rebalance, or not really rebalance, but adjust this accordingly, and I might change it. And so what I like to do is kind of set it to what I think will work, and then adjust it after you test it. So this is the pressure for the rear tires, and adjust it based off of what you actually experience after doing a couple laps out on track. And so essentially the higher pressure will drop grip, but it will actually help control the heat of the tires themselves. And so since you're drifting, you're going to be spinning the rear tires a lot. And so what we're going to want to do is get out and test and see if we need to make some major adjustments to the tire pressures to kind of keep the tires working in a good temp range. And so that's something that we have to actually go out and test. The reason I set it at 22 is just because you have the motor up front, and while this car is probably sort of close to 50-50 weight distribution, the rear tires are probably a hair bit wider, and there isn't as much weight in the back, and so I'll just run it at 22 versus 23 just because you're not having to support as much weight. On these cars with the Assetto Corsa Drift France team vehicles, they always come with a really low amount of fuel, so that's great for like an actual really short competition run, but for just having fun and practicing, you'll literally run out of gas in like 3 laps. So kind of bump this up a little bit just so it can survive. As you can imagine, a nearly 1,000 horsepower vehicle doesn't exactly get the greatest gas mileage. Alright, so here we are at the most important aspect of setting up a drift car, and this is your alignment settings. So what I tend to do is you can't really adjust camber, and it's already in a good range at 2.9 degrees of negative camber, and so we'll just leave that there and then come back after the test and evaluate. When it comes to the front toe, we want the car to be able to self-steer and respond to being sideways as quickly as possible. And so this might seem a little counterintuitive, but I find that running a lot of toe out, and in this case it's always, if you see the negative number, that's toe out. If you don't see this and it's positive, that's actually toe in. And so what I like to do is run quite a bit of toe out. And you can actually feel it in the steering wheel. And it doesn't matter what kind of steering wheel you have, even a Logitech steering wheel, you'll notice in Assetto Corsa, you'll notice the actual difference and in response with toe out settings. And so what's funny about these cars is that you can actually adjust it and break the car essentially. Like you can see here, I can set it to have negative, or not negative, but 5 degrees of toe out, which is insane. It kind of messes with the car. As you would imagine, it's like completely duck-footed and just plows the front end. So you need to be conscious of that. And so what I like to do is run 1 degree, and so I'm just going to tap over that just a hair, and we'll set the left side here appropriately. I'm going to keep it the same. So in this case it's negative 150 according to this, but I always look at the actual indicator here of what the car's actually sitting at with its under its own weight. When it comes to toe in the back, you want it as close to 0 as possible in a drift car, so the car actually has an easier time staying in a slide. And with a shorter wheelbase car, so generally speaking, a shorter wheelbase car, like a BRZ 86 like this, is always going to struggle with stability versus something like a Mustang or an E90 BMW. And so what I might do here is just add a hair, and I went the wrong way. There we go. So like I was saying, if you see negative, that's toe out. You definitely don't want toe out on this vehicle. And so this is actually just a little bit of toe in. But essentially we want it to be almost zeroed out because you want the car to just instantly and consistently go into a slide. You don't want it to grip up in the middle of a slide or on the exit or anything like that. And so we'll just do this just to keep the car in check. We can adjust accordingly afterwards. When it comes to camber, we want camber to almost be straight up and down in the rear. Because you're sliding the car, you're not putting a lot of side lateral force into the chassis. And so when it comes to actual drift setups, it's almost like you're setting up a drag car in the back. And so you want to maximize your grip. And so what will end up happening is, because you're not creating a lot of side force, because you're just not really producing a lot of traction since you're sliding the rear end around and spinning up the rear wheels, you'll actually find that the camber really likes being almost straight up and down. And so with this, you can see that we're at negative 0.19 degrees here. So we're actually going to run some positive camber. I'm actually going to zero it out, and I'll show you why I have logic with my logic with this. There we go. So you can see that it's zeroed out here. And now we're going to move on to our next category, which is brakes. We're actually not going to mess with this, and we're going to leave it at 100%. Sometimes, depending on the situation, I might actually drop the brake power down a little bit, just as kind of a security blanket. locking up the tires isn't exactly ideal, and it's hard to do because the temperature and traction available is is not consistent. Obviously, you're going to be really just burning up the rear tires, and so those will get superheated quickly and have very limited traction. And then the fronts don't get worked very much, and so they actually never. It takes them a while, and especially during a run, they won't actually get up to the proper running temp. So depending on how you have your brake bias set up, it's pretty easy to lock up the tires. And so if you don't have a lot of dexterity, or you just want that ease, you can drop this down to say 90%, and it just makes your life a little bit easier. But I actually have a little setup trick that I do so I can continue using this. And when it comes to the damper setting, I won't adjust this and touch the dampers until I've essentially set the mechanical grip of the vehicle. So I actually set the suspension first, and then I go back and actually dial in how the dampers work and change and fine tune the behavior of the vehicle. And so I think that's really important. I think a lot of people think that you can really like adjust the overall handling of the vehicle with the dampers, and that's how do I say this? This is a huge misconception. And so it's important to note that the dampers really just change how the actual grip that's being provided is portrayed to the driver. And so you can essentially, you can't really change like the actual potential of the vehicle with the dampers. And that's something that's a concept that actually applies to real life as well. Of course, in extreme situations, you can definitely change the behavior and mechanical grip, but in this simulation setting, it's more based off of well, it's not more. It is based off of what your suspension settings are. So our next category is the drivetrain category, and so with this, we actually have some like really generic baseline settings that we can run with the diffs. So this is Diff Power. What that's essentially saying is that when you're accelerating, how much does the diff lock up? And we want to run this at 100%. I mean, sometimes I'll drop it down to say 90. If it just depends on the car, and really kind of depends on like the course and what you're trying to get. So essentially, what this controls is how the differential, how it locks up. And so at 100%, anytime the wheels are at different speeds, it will make them the same speed. So it basically makes it so that at any yaw angle or slip angle, that the wheels are spinning at the same speed. So if you have a very like shallow angle, it'll be easy to keep the rear wheels spinning. So that's like super important in drifting, because you just want to keep the car sideways and rotating, and be able to do it with the throttle. So essentially, having it 100% locked ensures that whatever your right foot's doing on the gas pedal will be translated almost one-to-one with what the chassis is doing. And so it's more about driving the car with the accelerator and getting to steer like that. Differential Coast is for when you're slowing down, or really just any kind of deceleration. So if you're off throttle, it determines how much the vehicle locks up. So anybody who's like a grassroots type drifter, a lot of times they'll do what's called welding the rear diff, and so essentially that's 100% locked going forward or coasting or slowing down. And so while that's great, what that ends up doing is that actually makes it so the vehicle doesn't want to steer in. So imagine like a go-kart or something with a spool. So if you have this at 100%, if the vehicle's trying to turn, then the inner wheel can't go, or the outer wheels, they can't go at different speeds. And so what that does is that this really kind of controls the turn in, and also what the wheels are doing when you roll off the throttle. So if you need to make an adjustment and you're rolling off the throttle in the middle of a drift, or you're trying to adjust your angle, this deceleration differential setting actually really kind of changes that behavior. And so we want to run this pretty high, but it really just kind of depends on the wheelbase of the vehicle. Obviously, you would probably run it higher if it's a short wheelbase car, like an 8.6 or like this, or like a Miata or something like that. Or if it's a longer wheelbase car, you want that turn-in to happen, and it'll be more stable as you come into and out of drifts. And so you can run that a little bit lower. And so again, this is just one of those things that you kind of need to test and get a feel for the vehicle and how it behaves. And so the last setting that we have here is the actual differential preload. And so this doesn't, I think this is easy to confuse. So the differential preload in this case, and so it's not always the same depending on what kind of differential that you have. So in this case, the more differential or higher diff preload that you run, it actually makes the vehicle, it makes it a little bit harder for it to actually start locking things up. And so what it does is it adjusts the timing of the differential response. And so if, again, longer wheelbase cars that are going to be more stable, you're going to want to run this pretty low. And that's because it'll allow the vehicle to rotate and respond a bit quicker. But it doesn't change the overall characteristics. So this basically just adjusts like how, whatever these settings are, this adjusts how quickly it gets to this 75% decel or this 100%. And so if the car is really, really twitchy, or if it's a course that is high speed and requires a lot of stability, you would want to run this differential preload a little bit higher. So this is one of those things that you're going to have to test it and then make adjustments based off of what your needs are, either via vehicle or based off the course itself. And next is our generic, and with these cars in particular, they actually have like a power steering assist, and so I actually it's just based off of how much steering feedback you want, if you will, the strength of it, and so it gets pretty ridiculous. So I just drop it down to 80. If you do anything like 50 or something like that, it'll probably just run the maximum torque that your wheel can put out, and so it gets pretty obnoxious, and not in a good way. It's kind of ridiculous. It feels like a car with absolutely no power steering. So, but the 85 I find in the 90 is a little too light. So that's just a personal preference kind of thing. Here we have the brake bias, and like I was saying, what you'll find out, especially in Assetto Corsa, is that this setting is, the brake bias is a little difficult to set up in these cars, simply because the traction's like between the front and the rear is changing so much. Like even in the middle of a run, it's going to be changing. So what will end up happening is that you'll have superheated rear tires that aren't producing a lot of traction, and then you'll have front tires that are sort of getting up to their operating temp, and so it sort of keeps them even in a way. But a lot of times what will happen is that if you set this really low, while it sounds cool that, oh, I can press the brake and it will start locking up the rear tires, it actually makes the car really, really hard to drive, because these cars don't have ABS or anything like that. So if you actually do brake quite a bit and you start locking the rear tires, um, especially in the middle of a drift, or while you're after you've initiated a slide, what'll end up happening, it's like pulling an e-brake, except at the wrong time. So it'll just over rotate the vehicle and it'll throw you into a slide. So it's general rule of thumb is that it's always better to lock a front tire than it is a rear tire, because that's what you have the handbrake for. And you can see that lovely modeled handbrake there. That's what you have the handbrake for. Essentially, you can control what the rear brakes are doing that way. And so we are going to keep it here at 72%, because that will just really ensure that no matter how low the traction gets on these, because they're super smoked, it'll always be that the front tires, if we do end up locking them, will lock first. And I'm not saying that we want to be locking up brakes, but it's just, it keeps you safe, it gives you a margin, and so we'll leave it there for right now. You do have, I don't know why it has this. I mean, I guess you could, do some. I'll put this in air quotes. Video game specific tricks with this. You do have packer rates, and you can actually set the suspension travel range, and so this is like really great for having a high aero vehicle, and there's a whole bunch of theory with basically using the bump stops to control the suspension, and so we can adjust this, but and you can sort of use it as a little trick on these cars, but I mean, really, you're not going to be not so much. On the drift cars, they just don't generate really any kind of downforce or really enough grip. All right, so this brings us to our last category here that we're going to be using, and this is actually the second most important. So alignment's the most important, and then it comes to suspension. So this is going to be dialing in your mechanical grip for the vehicle, and this is super important. It basically just kind of determines like how the vehicle will drive, essentially. And so out of the box here, we can actually see that the car is balanced. So just go ahead and assume that this vehicle is really, really close to 50-50 weight distribution. It's a front engine vehicle, and the way that they have made these cars is pretty smart. So I mean, realistically, the vehicles they try to balance them to be 50-50 front and rear, and so because of that and that assumption, it can make it easier to kind of ballpark tune the car without having to go out and do a bunch of test drives and things like that. And so you can see here that our wheel rates are the same, so and they're pretty light. I want to say that 66. I mean, I'm not really keen on the whole metric system, but I want to say this is like a 400-ish pound per inch spring rate. But regardless, the car based off of this, and you can see that the anti-roll bar settings is at a generic. It's a generic number, but you can assume that the front is stiffer than the rear. So what that means is that this car is probably going to have a hint of understeer. You can see that the front is stiffer than the rear a little bit, and the wheel rates are the same, front and rear. So what I personally do on my drift setups is that I try to maximize the mechanical grip as much as I can, even though you're sliding the car. And so what I'll do is, like I was saying about that that front grip situation. So I can I think it's important to note that these are lightweight vehicles, relatively speaking, um, and then they're running. They're supposed to be simulating. I'll go back over here to tires. They're supposed to be simulating so the compound here is like really generic, but or not generic, but more of like whatever they say it is. And that's Assetto Corsa Drift, the France team here. And so it's supposed to be like a super high performance street tire. That's really what competition cars are using. So like a DOT legal super grippy tire. So think like a sub 200 tread wear tire, which is, I mean, that's in modern times, that's really grippy. And so because of that, um, we know that it's, even though we're sliding, we're still going to be producing a decent amount of grip. But I'm actually going to leave it here at the 66 because I was saying earlier that you just don't work the front tires that much. You're sliding the car the whole time, and so they don't actually get up to their grip potential that they could be. Or they do, but it'll happen after like literally 2 to 3 laps. And so that's when it comes to braking and just being able to maximize that front grip, we are going to actually leave this here. Now, what does end up happening with these cars, which is pretty interesting, is that even though we're sliding them, and that's kind of the point of drifting, the key to the game is to focus on rear grip. And so we actually want to maximize how much mechanical grip you can actually get. And so I'm going to drop this pretty low. And so as you change the spring rate and drop it lower, what ends up happening is that you have more vertical load happening over the rear as you accelerate. Now, it's important to note that when you're sliding, you're producing less grip than you would be if you were actually driving cleanly and using static friction. And so because of that, we can drop this obnoxiously low. And so I'm going to do 40 for right now. So what will happen is as I accelerate, the rear end will squat, and that will actually help with gripping and getting the car to drive off the corner. Think like a drag racing setup. And so we want the car to kind of hunker down and really just get a lot of vertical load over those rear tires, and that'll help us accelerate off the corner and make it so that it's easier to drive with the throttle. And so what I like about Assetto Corsa, I think it's really important to note, is that as I've dropped the spring rate, you can actually see that the rear ride height has changed. And so, and not in a good way, we actually want it to be back a little bit higher than the front. And so what we're going to do here is raise the rear ride height. And what I like to do is just kind of see like how high I can actually get it. And so I'm at 88 millimeters, which is pretty it's pretty low. And so I'm going to run that at 90. So you can see as I increase the spin rate a little bit, you can see that the car actually raised a little bit. And so what I'm going to do here is we're actually going to lower the car to make sure that we can maximize the weight jacking, if you will. And so I am going to drop the height down. course, keep it even. And what I mean by weight jacking is that whatever end is higher, so when it comes like front or rear, whatever end is higher will actually be carrying more weight, and so that's like when weight transfer happens. And so like if you were drag racing, for example, and you had the rear end higher than the front, that would actually promote more weight transfer when you accelerate. And so that's what we're trying to replicate in this situation here. So I'm going to go ahead and lower it, and I'm actually going to drop it to, there we go. So we have it at 85 millimeters. And the reason that we don't have it slammed all the way down to 75 millimeters, which is the minimum, that is really just because I mean this is like barely this is barely like 3.5 inches of ground clearance. That's like nothing. And so when you start slamming things that low, you just really give up a lot of suspension compliance and things like that, and you make your life you make your life a bit more complicated. And again, what I really like about Assetto Corsa is how you have to be conscious of the suspension geometry. So you can see that as I've lowered the car a little bit, you can see that the toe angle, which is toe out 1.7 or 1.07 degrees, as the front end of this car lowers, the car toes in on the front. and so and you can actually see back here, I had the car with a little bit of toe in, and you can see now that it has changed where it's actually, instead negative number, or a negative sign. It means that the car, as the suspension goes through the travel, that it actually has a kind of bump steer situation going on, or kind of a dynamics alignment change, and the car actually has some toe out happening, and that's we still want to take advantage of that mechanical grip increase with the vertical load, but because of this, what that means is we need to go back to our alignment, and we want to actually add in some toe in, because we know that as the car goes through its stroke and starts to squat down, it's going to be toeing out a little bit, and so we want to make sure it doesn't kind of get into a full toe out situation, and that's just going to make your life miserable. Essentially, as you get on the gas and the car squats, when it toes out in the rear, it'll want to just keep it'll just want to keep rotating, and it'll get away from you. So we are going to adjust this, and we're going to give ourselves a little bit of a margin here. And so we can see that even with that lowering, that it only gained 0.012-ish degrees. So we're actually going to run 0.1 in the back. And we'll try that. We can make adjustments accordingly, and all of that. Oh, we can also see that as we lower the car, the camber actually changed quite a bit. So we'll need to readjust that, get as close to 0 as you can. And like I said, because we have the suspension so soft, as it squats down, it'll actually gain camber. And so that's why it'll help with having that contact patch being maximized, because as the rear end squats down under lateral load because you're sliding, it will actually help with keeping the contact patch solid. we're not going to sweat too much. In drifting, you actually do run quite a bit of camber, just based off of the fact that you're counter steering so much that having having like almost 3 degrees of camber is probably going to be pretty bang on for what we want. And other than that, we're going to make one final adjustment. And so so the other thing too is that with these cars, you want to run quite a bit of you want to run these cars because they're producing so much grip, relatively speaking. Is that you want to run quite a bit of anti-roll bar. You want the platform to be pretty stable, and so I'm gonna leave it. I'm gonna bump it up a little bit here, but and that's just because you're running the springs like super soft for the platform. And so we can use the bar to really kind of control the lateral load. That's what it's there for. I mean, that's really what an anti-roll bar is there for, is dealing with lateral loads. And so we want to run these pretty stiff. And what I like to do is, and this is just going to be pure guesswork, is I'm going to run these pretty even. Some of the other cars, like the World Drift Tour cars, I like them a little bit more because they use actual, measurements instead of just using like generic numbers like this with the anti-roll bars. Like, I don't know what 35 is. I don't know what that stiffness is. And so I'm just kind of like guessing based off of the bar, assuming that they're using the same exact bars, front and rear. And the reason that we're going to make them even is because that'll ballpark us. So the car might have a hint of understeer, since these are pretty much even. But and the reason it'll have understeer is just because, or it might be even, is simply because we have the rear so much softer. So it's always important to remember that your spring rates also help with your roll rates. And so obviously if you have a stiffer, whatever side, like front or rear, or end I should say, that has the stiffer suspension setting, that's the same as having like a stiffer front bar. And so we're going to have to go and test this out and see how the car actually behaves. All right, so again, I haven't driven this car, so it might be a little messy, and we'll have to see how it actually drives. So right away I can tell you that the steering feel feels pretty good, so our toe out settings on the front are probably pretty solid. The car steers in well, and so you can see it kind of stepped out of the drift right there. Now let's see how it does here. So it's a little understeery. It wants to get out, but the tires haven't fully heated up yet. And we'll see how it transitions throughout here. Yeah, there we go. Note that I actually haven't touched the e-brake once this whole entire time, just because we have the car so balanced. And that's the big thing, I think, with setting up the drift cars, is just getting the suspension balance so you can minimize how much handbrake you need to actually initiate the drift. It makes it feel really natural and just makes your life easier. That's the key with doing setups, is to make the driving part easier. So as the you can see that the front tires are green in that little indicator, and they're up to temp, and so they're producing as much grip as they can. Maybe not that right side so much, but oh my goodness. And then the rear tires, you can see they're orange, so they're overheated, and that's why the car all of a sudden is handling better, and it has very, very neutral, almost oversteery feel now. And so that's what I was saying about it changes, and so just kind of like figure out like, well, how much of the run do I want? So I could have set the car up to oversteer a little bit more with the bar settings, but since the rear tires got up to temp pretty quickly, or over temp, that the car actually ended up having a handling change, and so that's important to keep in account, is how the car's handling will change based off the tire temperatures. Again, I still have not used that handbrake at all. One thing I will say is the car gets pretty rowdy off throttle, and so that might be something that we want to adjust. And you can see that my left rear has already gone in the red, so that means that the tire's just cooked and it's done, and that really changes the handling balance because the tire's considered just basically completely cooked, and so then the car actually gets really oversteery. So we have to almost just breathe on the throttle here, and now officially both tires are done, and you can see the car really oversteers now. And so that was our initial test. I came to a complete stop, and you can see that left front actually locked. So that's what we were looking for. Even when the tires have like no traction, we still want the car to behave in a way under the brakes where the front end is, if you are accidentally going to lock a brake, that it locks up first. So the car ended up handling pretty well. I'm actually going to back off on this a little bit, and we can see that we can see based off the tire temps that the front is actually a little low, but that's why the temperature is a little bit lower here. That means that the tire pressures they're not high enough, and so it's kind of sagging on the sides, and the tire's concave in the center. And so, but tire wear wise, that negative almost 3 degrees of camber was like spot on. And that's what I was saying, like with the setups of these drift cars, it's like they're really unique and kind of extreme, specific to that. And so, and you can see like the tire itself actually ends up overheating, and it runs pretty hot. And so, I mean, this is in Celsius, so I don't even know what that is, but I'm pretty sure you could like bake with that kind of level of temperature. And so I'm actually going to leave that there. So we kind of ballparked it, and I've done this a lot, and so I just really know how to kind of set these cars up pretty well, and it feels good. One thing I did want to adjust is that I want to make the car steer a little bit better. When I get off the throttle, I notice that the car wants to keep rotating, and so that's where that differential coast setting can come in. The dampers honestly felt pretty good. Um, I mean, we could do some tweaks, but I just need a little bit more driving time. Um, the car wasn't really doing anything that I disliked, um, and I could make another video just on damping and how you set that up and just how the car overall behaves. Um, but other than that, yeah, the car feels good. So I'm gonna go ahead and um, bump that up a little bit. But yeah, there you go. That's kind of how you set up a drift car. Hopefully, it gives you some ideas and things to think about.